All right, y'all, so when we talk about solving, we are specifically going to talk about our exponential functions right now. So we always know that we can check our work using our graph and looking for our x-intercepts, or we can use it, we can check our work using InSolve, which is menu 3-1 on the calculator. But today we really want to focus on how to do this algebraically. So I know that to undo an exponential, we said our inverse or our opposite is going to be our logarithmic function. So let's say that I have something like, so let's see, 2 to the x power is equal to 4. So the first thing I notice is that I have my variable and my exponent, which means I know I have exponential. Then I want to think about ensuring that my exponential function is alone on one side of my equal sign. I see that my blue box, right? I'm going to start drawing that blue box where my base begins right here, and then I'm going to finish it wherever my exponent ends. So I see that it is alone on one side of my equal sign. So I can go ahead and log it. I'm going to undo it. So I do this by log, and I keep my base, so log base 2, log base 2. On my left side, these will cancel out, and I'm left with x. And on the right side, I have log base 2 of 4. All right, you guys, at this point, I can type log base 2 of 4 into my calculator, and I will get my final answer. But in total honesty, I'm sitting at my desk at home, and I don't have a calculator, so that's where we are going to leave it. All right, let's look at another example, though. Sometimes it is going to be a little bit more complicated. We could have 2 to the x plus 6 equals, we'll say, 9. So we'll switch up a little bit. I know that when I'm solving, I always use PEMDAS backwards. So the first thing I want to think about is drawing my box. So I know I'm going to start my box right where my exponential starts, or where my base begins. And I'm going to finish it wherever my exponent is. All right. So I see that my blue box is alone on one side of my equal sign, so I'm going to go ahead and log it. We're going to log base 2 both sides. On the left side, my log base 2 and my base of 2 of my exponent will cancel out, and I'm left with x plus 6. And on the right side, I now have log base 2 of 9. All right, but I want to get x alone, so I want to think about PEMDAS backwards again. I see I have some subtraction, or I have addition, excuse me, so I want to undo that addition with subtraction. So now I'm going to end up with x is equal to log base 2 of 9. I see that 9's in my argument, so I cannot subtract my 6 from my 9. So we're going to have log base 2 of 9 minus 6. And when I type that in my calculator, I will get my final answer. Let's look at one more. So what would happen if I had 3, we'll say 4 to the x minus 1 plus 6 equals 24. All right, so this is going to be one of the most complicated that we'll see. So let's go ahead and draw my box, right? What can I not, like, what do I want to get alone? So I started my line right where my base begins, and I'm going to finish it where my exponent ends, right at that minus 1. So if I'm looking at PEMDAS backwards, so we're going to come back up here. I'm going to start with subtraction. I don't have any subtraction. Looking for addition. I do have that plus 6. So let's undo that first. I'm going to subtract 6 from both sides. And now I'm going to have, on my left side, 3 to the 4x minus 1 equals 18. Still thinking about where my exponential function is. It is not alone. I got to get rid of that 3. Since there's no sign in between the 3 and my exponential piece, I know that means multiplication, and I'm going to undo multiplication with division. So on my left side, I'm left with 4 to the x minus 1 power is equal to 18 divided by 3 gives me 6. I now have my exponential alone, and I know I undo exponential with logarithmic. So I'm going to log base 4 both sides. And on my left side, it's going to cancel out. I'm left with x minus 1 is equal to log base 4 of 6. To finish, because I still want to get my x alone, so I need to get rid of this minus 1. I'm going to undo it using plus 1. So we'll finish with x equals log base 4 of 6 plus 1. When I type this in my calculator, I will get my final answer. Again, I can always check this with my calculator using InSolve, which would be menu 2, 3, 1. When that pops up, it'll look something like this, InSolve. And then we will type in our original equation exactly as we see it. So we'll say 3 times 4 x minus 1 plus 6 equals 24, comma, I'm going to say my variable, so we'll have comma x. Y'all don't forget to arrow over to get out of your exponent. Good. Exponent. All right, you guys, y'all are rock stars. Let me know if you have any questions.